So today we discussed the fact that task-based fMRI experiments are typically centered on the idea of relative comparisons. You're almost always looking at the activations for a certain task of interest compared to some other baseline or comparison or control task. And see, the reason is that bold data is not easily interpreted in quantitative ways. To give you a comparison, a positron emission tomography data can be interpreted quantitatively. So if you get a positron emission tomography scan, you can interpret the data as cerebral blood flow in terms of milliliters. You can look at it and say, okay, so in this part of the brain, there's this much milliliters per some unit of time cerebral blood flow. Now with fMRI, with bold fMRI, we can't do that. So we're tied to always have to look at brain activity in some task of interest versus brain activity in some comparison task. And we've also said that most typically, we want to compare two different cognitive tasks that differ only in one thing, process that you are interested in studying. And this is known as the pure insertion hypothesis, the idea that you can add one more cognitive process on top of other cognitive processes without changing how your brain processes all these other things. Now, we've seen several different experimental designs. And importantly, you should keep in mind that none of these designs is in absolute preferable over other designs. It really depends on what you're trying to achieve. All of them make assumptions. Often they just make different assumptions or different versions of the same assumption. Now, I would suggest that in your next experiment, if possible, try to see if you can use your own data to address some of these assumptions. You might be able to address some of these assumptions in a quantitative manner. And if you can't, it's fine. Just discuss the possible limitations of whatever approach you're doing. It will help you and the reader better understand and better interpret your data. And finally, which design should you pick? Well, it depends. As I said, there isn't a perfect design. There isn't a right or wrong design. It really depends on what you're trying to achieve. So you should probably pick the design that is just most consistent or that best fits what you are trying to do in terms of the type of task that you want to use. And most of the times, the appropriate way of doing this would probably be to ask the same question, but with different experimental designs in a way to triangulate towards whatever might be the real underlying result.